So see, why I have taken this much on understanding you the Active Directory, right? Why? Because see, when I was starting to make my career in cybersecurity, and when I wanted to learn about Windows red teaming, there are courses who teach Active Directory attack vectors, but I did not find a course that taught me Active Directory basics in detail. So all the courses generally talk about curb roasting, NTLM relay attacks, and other kind of attacks, but not the basics part. Okay, so that's where I was finding it difficult to learn about Active Directory attacks because I was lacking the basic knowledge of Active Directory. So even the people who are directly jumping on the attack part, they will struggle because they don't know the basics here. So again, as I said, cyber kill chain is just a methodology that cyber professionals uses to successfully execute an engagement. You start with external reconnaissance where you are outside the network and you are basically, let's suppose there is outside the company is hosting a website and you have hacked that website to get and then get a remote code execution on a machine that has hosted that web server, and now you have a foothold on that machine, and then you saw that this machine is part of the internal network. Basically, you are able to reach the internal network from that machine, and once you have that, you will try to escalate your privileges on that particular machine. Basically, from a normal user privileges, you're trying to get to the admin privileges so that you can do anything you want on that particular machine, and from that machine you try to compromise some other machines. Okay, let's suppose from this machine you're trying to, let's suppose there is a machine A, from that machine A you have compromised machine B. Now you have a foothold on machine B, and on that B machine, computer B machine, you will again try to escalate your privileges, and from that machine B you will again try to move laterally to some other machine. And once you get to a machine where, let's suppose on that machine, on the user's desktop, domain admin's credentials are saved, so you can easily get to the password of domain administrator. And when I'm saying that on a desktop a domain admin password are saved, believe me, in my real world engagement I have seen that. So that can happen in an engagement. And then once you compromise the domain, you basically can go for dominance, or you can persist yourself. I hope that makes sense, brotherhood. Okay, so now let's go to the very, very fun part, which is the attacking part, which is NTLM relay attack. Okay, again, in whatever courses I have taken on Windows red teaming, or let's suppose Active Directory hacking, this is the one attack that they are missing out. They are generally teaching about curb roasting, ASRAP roasting, domain trust attacks, but this is the real stuff that we do in our engagements. Okay, so let's give an example. Just to give an example, so at Redfox Security, we deliver around 200-300 engagements per year. I myself have delivered about 70 to 80 engagements last year. Okay, so and I've been doing this from past few years, and in my Windows red teaming engagement, generally I think a single scenario I have seen that I have compromised a user password using curb roasting, right? So that's how rare it is, this curb roasting and ASRAP roasting. But this attack, NTLM relay attack, has given me a user's password or given me access to a machine quite often. Okay, so whenever I start with an engagement, I generally run this attack, which is NTLM relay attack. That's what is missing in the courses out there. That's why we have implemented this. Basically, in the courses that we have launched at our academy, whatever real world scenarios that we are seeing, right, we have put that in that course. And I think that in India probably we are the ones who is doing this large amount of engagements. Okay, so let's start with the NTLM relay attack. Okay, fun part here. Yeah, one thing here, guys. Okay, before going to the attack path, one important thing here, right? That attacks that I am going to showcase here, right? Please do not use these attacks on on real websites, on real engagements without any authorization. Okay, whatever attacks you are learning, you can use those attacks in your own lab, or if you are doing on some real world network, then please take the proper authorization before that. So that's the disclaimer here, because Redfox security will not be responsible. These are very, these attacks can easily get you something. So that's why you are going to get in trouble, right? So we don't want you guys to be in trouble. This is just for educational purposes, and so that also for the as a job perspective. So you can learn these attacks and you can apply these on your jobs, not in the real world. Don't do that, because I have seen people going in trouble, believe me. So again, yeah, NTLM relay attack, right? So let's start. So what we will get to cover, we will again, I really love the basics thing. So we will start with the basics of NTLM authentication. Then we will see how does name resolution works in Windows. Then we will see what is LMR and NBTNS, MDNS poisoning, and finally we are going to see NTLM relay attack. Okay. So first of all, let me draw a few things. So this is the client machine, okay, and this is the server machine, and this is the domain controller. So let's call this client machine WS07. This server machine is Web01, and this is DC02. Okay. As I said, all the users' password are stored where? On the domain controller. So let's suppose there is a user called Sam. So this user's actually the user password is not stored, but the hash of that user's password is stored. So basically you hash that password, that Sam's password, and store in this domain controller. So let's suppose the hash of that user, just for simplicity I am writing 10 here. It can be, it is a 32-bit character, the hash. But just for simplicity, let me just write down the hash of this user. It's just 10, okay. And this client computer also has the NTLM hash. So this is the NTLM hash. Let's call it NTLM hash. Again, this Sam has the NTLM hash, which is 10. Okay. So this hash again is the hash that is generated from a user's password. Let's suppose the user password is password 123. Then the hash is going to be a random character, so 32-bit, not a random, but a NTLM hash for that user's password. Let's suppose this is 10. Okay. Again, yeah. So as I said, all the user's password plus all the computer's password are stored on the domain controller. So domain controller already has a copy of Sam's hash. Okay. Cool. I hope that's clear now. Okay. Now this client wants to access a share from that server, right? What will happen? As a first step, the client will send a authentication request to the server. The server will see that the client is trying to access this share, and they have sent a authentication request. Okay. In response to that authentication request, the server will send a NTLM challenge. So again, NTLM challenge is a random characters. So for simplicity, let's say that this system has sent a challenge of 20, just for simplicity. Now the client has the NTLM hash, which client already has the NTLM hash, and now it has the challenge. Okay. Now what the client system is going to do? The client system is going to take this hash as a key and encrypts this challenge and generate a encrypted value. So let's say, I think it uses MD5 algorithm to do that. So it will take this NTLM hash as a key and take this challenge as a value, and then encrypts it and generates an encrypted value. Let's call it the value as the response, or value as 30. Seems simple, right? Just suppose this MD5 is doing nothing but a addition operation. So the response will come out as 30. Okay, simple. Now this client machine will send this response, which is 30, to this server machine. Okay. So yeah, now it has reached to the. Now this server machine, what it will do? It will send the challenge, this challenge, which is 20, plus this response, which is 30, to the domain controller. Okay. Now both the challenge and response has reached to the domain controller, and as I said, domain controller already has the hash, which is 10 here. Okay. Now this challenge, it has come to the domain controller. Now it has the challenge as well. Now what the domain controller will do, it will apply the same MD5 algorithm, uses this hash as a key, 20 as a value, the challenge as a value, and then encrypts it. I think it uses or it will hash this using the MD5 algorithm, and then it will generate another value. Basically, it is also doing this, applying the same algorithm here. So let's suppose it is applying the addition algorithm here. If you see 10 plus 20, it comes to 30 here. Okay. Now this response, it will try to compare the responses. So the first response that it created and the second response, which this one is. Okay. Now it will compare this response with this response, which is also 30. So if 30 equals to 30, it means the client is holding the correct NTLM hash, which is 10. Same here, 10 here. It means that client has the password and is the correct client. And now what will do? The domain controller will say that to the server, hey, the authentication is successful to the server. Now server knows that this is the legit user. Now server will look at the share permissions and see whether that user has access to that share or not. If the user has access to the share, the server will give back the share to the client. Okay. I hope this whole NTLM authentication now makes sense. So that's how NTLM authentication works. So this is one of the authentication. Yeah. Now let's talk about how does name resolution works in Windows. So all the basics I am teaching you here, it is basically geared toward the NTLM relay attack. So that's why I am going through the basics here. So how does name resolution works in Windows? So before that, what is a name resolution? So name resolution is nothing but mapping IP addresses to host names. Okay, mapping IP addresses to host names. Correct? Okay, let me just do one more thing here. Because why we need this mapping of IP addresses to host names? Why? Because IP addresses were very hard very hard to remember, right? That's why we use host names like Web01, Workstation 07, DC02 as domain controller, right? The host names are very easy to remember, but the IP addresses, it's a pain to remember, right? So that's why this name resolution is there in Windows. So whenever you are going to google.com, it means that google.com has a mapping for IP address. So IP address is the actual address of that server machine who is hosting the google.com. Okay. Yeah. So how does name resolution works in Windows? Okay. So let me just draw here. So let's suppose this is your computer. This is a server here. This is the domain controller or DNS server. So generally, domain controllers are the ones who is providing the DNS services. So this computer wants to access this server. Okay. So first thing it will do, it has to know the IP address of this machine. Okay. So the first thing that it will do, it will first try to find the mapping of the IP address to this host name in its cache, in its DNS cache. If it is not there, then it will again look for its in this file, etc host files. If the mapping is not there, then what it will do, it will send a lookup request to the DNS server or to the DC, and will ask the DNS server or the domain controller, hey, do you know this address? Let's suppose the Web01. So do you know where is Web01? And if DC has the mapping of this machine, it will send back. If not, then what it will do, it will broadcast these messages, these queries, which is link local multicast name resolution, or net BIOS name resolution, or multicast DNS. So it using these protocols, it will send these name queries in the entire local network. So basically, if there are like multiple computers, it will ask each and every computer, hey, you are Web01, hey, you are Web01, hey, are you the Web01? And the machine who is Web01 will respond back to its IP addresses. Okay. If there is no Web01 machine, then we will get simply that you are not able to access the share. That's what you will get, right? So that's how name resolution works in Windows. So if it is not able to find its cache or in domain controller, it will try to use these legacy protocols to find the web server. Okay, so that's how name resolution works in Windows. Okay, same thing here. So let's suppose you are trying to access this C share on this server machine. Okay, before that you have to know the IP address of this server, right, to access this C share, right? What will happen? First thing, let's suppose the location, the IP address of this server is not present in its cache or in its host file. So what this victim system will do? Let's call this a victim system. This victim system will send now a DNS query to this server for this DC02 DNS server or the domain controller, asking for, hey, do you know the IP address of server 02 machine? And if this domain controller has a mapping of this server 02 to IP address of the server 02 machine, which is at this address, if it has that mapping, it will send back to the victim, hey, here you go, server 02 is located at this IP address. And once when this victim knows that the server 02 is located at 10.0.2.24 IP address, it can directly reach to this server and access the C share here, and then the server will spawn back to the victim. So that's the only MD5 hash is used. That's correct. I think it was one of my questions. That's the only MD5 hash used for hashing in NTLM authentication. Yeah. So not MD hash. MD5 is the name of the algorithm, and the hash is the NTLM hash. Okay. So if you see the response, if you see all the network traffic in Wireshark. So what is Wireshark? Wireshark is a network capture tool. It will capture the traffic that is coming in and out of a computer. Okay, so let's see. Again, let me guys remember this. Let's suppose that 32 is the victim machine, 16 is the DC or the DNS server, and then 24 is the server. Okay. Now, as I said, what will happen? The victim machine will send a DNS query. If you see the DNS query, victim machine will send a DNS query to the domain controller looking for server 2 address. So that's the name of the domain, consultant.redfox.local. This is the name of the server. And if domain controller has that mapping, this mapping, this DNS name to this IP address mapping, it will send back to this domain controller now send back to the victim machine the IP address of the server 02 machine. Now this victim system, if you see here, now this victim system will go to this server machine and ask the DNS share, and then the server machine will send the share to this victim machine. Okay, I hope that makes sense in this Wireshark logs. So that's the general flow when the domain controller knows the IP address of the server machine. So have you ever imagined what will happen when you try to access a share from a server, and maybe you mistype the name of the server, or maybe that server is now not present in the network? So what will happen at that time, right? So that's where the attacks comes in. Okay. Now what will happen? Let's suppose now victim machine, the user on the victim machine trying to access the server 01 server. Okay. But that server is not present in the network, right? So the victim machine will try to find it in its cache, which is not there, the IP address of the server 01 machine. Then it will send a name resolution query to the DNS server or the domain controller. Basically, the domain controller also acts as a DNS server. Okay, it will ask the domain controller server 01 IP address, since there is no server 101 machine in the network, or maybe there might be one, but it is now not there, and the DNS server don't has the mapping. So what the DNS server will send back? Hey, I don't know what server 01 are talking about. I don't have the IP address. What will happen? The victim machine will fall back to the legacy protocols, which are LLMR, NBT, NBTNS and MDNS, which are broadcast in nature. It means it will ask each and every computer in the network, hey, do you know where is basically, are you the server 01 machine? It will ask to each and every machine. Okay. So that's what will happen when there is no mapping in the domain controller. And if you see, again, if you see, same thing happening here. Let me just open this one. Okay, if you see again, same thing here, right? Same thing here. The victim machine will ask the domain controller looking for server 01. And what server 0, what our this DC machine will respond back? That, hey, there is no such name as server 01. Okay. And this is the domain controller. So there is no server 01 mapping I have. Now what this victim machine will do? It will send broadcast messages. If you see, it is sending all these broadcast messages to each and every machine. Okay. And looking for the server 01 machine. So that's what happens. It will send the broadcast messages in the entire network. Let's go to the next slide. And if there is no server 01 machine in the network, you will simply get this error, is that Windows cannot access this share. Why? Because it don't have the IP address of this server 01 machine. Right? Okay. Now you are acting as an attacker, right? So now you are, so assume yourself that you are in their network, right? Let me draw this one thing again. Okay. So again, same scenario. This time, you are as an attacker, you are also already in their network. Okay. Now what will happen? Again, this victim, the user on this victim machine wants to try to access the server 01 machine, which is not in the network. It will first ask the DC, hey, do you have any idea about where is the IP address of the, what is the IP address of the server 01 machine here? The DC will simply say, no, I don't know, because I don't have the mapping, because there is no server 01 in the network, right? That's what it will say. It will send, it will say. Now again, it will send the broadcast messages in the entire network. It means it will ask each and every computer or server, hey, are you the server 01 machine? And since as an attacker, you already have your machine set up in their network, when that since this broadcast messages reach to each and every computer, that message will reach to you as well. It will ask you, hey, you are the server 01 machine. And you can simply say, yes, I am the server 01 machine, right? And then you can fake it, right? You can fake it, fake this, fake the response that, hey, I am the server 01 machine that you are looking for. And if you want to access the share, you can access it, but you have to provide your credentials. And the victim machine will simply thinks that the response is coming from the right server, and it will simply send the credential of that user to the attacker machine. That's what is happening here. It is asking the attacker machine, hey, do you know server 01 using the broadcast messages? Attacker will simply say that, hey, I am the server 101 that you are looking for. And if you want to access that share, you have to provide me your credentials. Okay. Now the victim machine will simply think that, hey, it is coming from the right place, right? Because it responded. So that's how things works in Windows. Okay, it will not validate whether that server 1 is the correct server 01. Then it will simply send the NTLM v2 credentials. Why I am saying that NTLM v2, not NTLM? More on that later on. It will simply send back the NTLM v2 credentials to the attacker. Now attacker has the credential of that user who is trying to access a server from a server that is not present in the network. Okay. So let me just close this one. Same thing here. If you look at the network topology here, same thing here. This workstation machine will send the broadcast messages to each and every computer. You see, this computer, this DNS server, as well as to the attacker machine. Looking for this. This victim machine will simply say, hey, okay, let me just draw this thing quickly. Basically, this will reach, this is a broadcast, it will reach to this machine, this machine, this machine, this machine, and this machine as well. And since there is no server 01, as you can see, we can simply respond that server 01 is at this IP address, which is the IP address of the attacker. Okay, it can spoof the response for this query. Now this query reaches this workstation machine that server 01 is located at 20.15. And from now on, all the shares that it trying to access from the server 01 machine, all the authentication, all the request for that share will reach to this attacker machine here, because it thinks that this server 01 is located at this address. Why? Because we have spoofed the response. If you look at the Wireshark logs, see, I am going at the protocol level. Why? Because you will be able to understand things. That's why. If you see, now this will make more sense now. Again, let me just quickly here write there 32 victim, 16 DC, 24 server. Oh, so there is no server 01. So server 01, there is no one, no machine. So let me just write server, and 15 is the Kali machine IP. Okay. Same thing here in the Wireshark logs, that this victim machine asked the DC, do you know server 01 IP address of this server 01 machine? DC simply responds, there is no such name as this server in my table. It will send back. Now this victim machine will send the broadcast messages. Okay, so these are the broadcast messages, and if you see, this broadcast message will reach to the attacker machine as well. Okay, and what simply we can say that, hey, I know I am the server 01 and I am located at 10.0.15 address. That's what it has told this victim machine, that this server is also located at the address, basically on the IP address of the attacker machine. Now from now on, all the queries the victim wants to send to the server machine will reach to the Kali machine, because they both are at the same IP address. Okay, and if you see, now from now on, all our queries from the victim machine are going to this attacker machine. You see, all of them, there is a back and forth going on. Basically now it is trying to access the share using the SMB protocol. SMB is the protocol that in Windows that is used for accessing the files. So now from now on, victim is trying to access the share from our attacker machine. And what we simply can say, that before accessing the share, you have to provide your credentials, and if you see, it will say that, hey, negotiation required, which is asking for authentication, and then this system will send the NTLM v2 hash of this user who is trying to access the share, which is consultants. Consultants is the name of the domain, and test is the name of the user. Okay, and once the attacker machine gets the access to the credentials, it can simply say, hey, access denied, you don't have the access, right? Because it already got the authentication or the NTLM v2 credential of this test user. If you see, what I have done, I have made this request a bit larger. I have expanded it. Basically, if you see, this is the request. So that's this is the request. I expanded. If in this request, if you see, there is the NTLM v2 response. So that's, if you see here, that's the NTLM v2 hash of the user. Now we have that. Cool. I hope I am making sense here, guys. I hope you guys know how attacker can abuse the legacy protocols to get access to the NTLM v2 credentials of a user. Now let's show this practically, right? How you can do that. So basically, in our engagements as well. So when we when we kick off our engagements, what we will do? We use this tool, which is the responder. So responder is the tool which can poison the legacy protocols, LLMNAR, NBT, MDNS, and much more. It can poison the responses of these protocols, and it will host up a fake SMB auth server. Okay, so basically this is my attacker machine. I have used ran responder, and the responder will spawn some fake SMB server, so it can first poisons the response, and then when it tries to access the file share from our SMB server, it will ask for the authentication. Okay, that's what responder does. And this is the command responder dash capital I for the providing the interface. eth0 is the name of the interface. So again, guys, all the tools and techniques and attacks that I am showcasing here, don't do it in real world. Okay, do it with proper authorization or try it in your own lab. Again, for you guys it is very hard to create a lab. So the course that we are providing at Redfox Security, in that course we are already giving you a lab, so that it already has all these attacks set up that you can practice there. Okay. Now again, let's suppose there's my engagement has started. Okay, on the first day of my engagement, what I have done, I have ran the responder 2, and you see the engagement when we are working on, we are talking about thousands of computers, hundreds or thousands of computers, right? It's not a small lab. So in thousands of computers, there is high chances that someone might make a mistake of typing a wrong share, wrong server name, or maybe there is a scheduled task that is trying to access a server, and now that server is not present in the network. Now that script don't know where is the server location, right? So that's what we also do. We also start with use this responder tool and keep it running in the background. And let's suppose a user wants to access a wrong share. It will send broadcast messages to all the computers, and it will reach to us. And then what we will poison the response and ask when it tries to access the share, we will ask for their NTLM v2 credentials. So that's how NTLM v2 credential looks like. Okay. So you cannot use this hash, which is the NTLM v2 hash. You cannot use this hash to simply log in to using directly on a interactive login. You cannot do that. You cannot just on your login screen you can add your username and this hash to get login in. But you can, using this hash, you can access files and other services from the network. So and another thing about this hash is that this hash you can crack. Okay, you can crack this hash to get to the clear text password. That's other thing you can do using cracking tools here. And that's the hash. That's the tools that you can use to crack the hash. Okay, so let me demonstrate this again, guys. Please don't do this in a real environment. Okay, so let me show you the practical, right? We will go step by step. Okay, so let's suppose my engagement has started. Okay, so I am teaching you what we basically do in our engagements as well. Okay, let me just log in to my Kali machine. So this machine is already in the network. Cool. Let me just, I hope this is visible. Okay, let me just increase the size again. I hope it's visible now. Sorry. Okay, so what we will do, we will let me see the interface. So this is my network. So my network is my lab network is hosted at this subnet, which is 10.0.0.0/24. This is the IP address of my Kali machine, and that's the interface that I have. So what I will do, let me just do one setting. Okay, again this keyboard is anyways. So let me just see the configuration of the responder first. So that's not the by default setting. So in the default settings it will be, so I have changed it, but yeah. So that's the default setting of the responder tool. It means that the responder will start these fake servers. It will start SQL, SMB, Kerberos, FTP, HTTP. So all these servers it will spawn when we run this tool, basically so that it can answer to the request that is coming to these protocols. Okay, let me just save this. Control X. Okay, again Control X, Y. Okay, so that's the default configuration. In default configuration, it will start these protocols. So right now focus on the SMB protocol. It's already on. So it will start up a fake protocol SMB server. Responder -I for interface, then ETH0, which is Ethernet 1, sorry, Ethernet ETH1, which is the Ethernet 1 is the interface that I am going to listen on. If you see, now it has started poisoning these responses, sorry, these queries. It has started poisoning these queries, LLM, MDNS, DNS, DSCP, and it has started these fake servers. Okay. Oh yeah. So SMB server is on. Okay. So again, in a real world engagement, let's create a scenario where, let's suppose a user who is sitting on this WS0 machine. So that's the client machine, right? So user who is sitting on this machine try to access a server. Let's suppose, let's again go for server 01, which is not present in the network, and they try to access the C share. And if you see, once I have done that, and if I go back to the Kali Linux machine, if you see, it has already started poisoning the responses. If you see here, okay. So looks like the hash is skipped here. I will quickly fix this. Don't worry about that. Okay, let me quickly do that as well. Okay, I think I have already, in this lab I have done this, so that's why it's trying to do that. Okay, let me do one thing. Control C. Before that, remove. Basically, this hash is already saved, so let me remove all the logs and remove responder DB. Okay. Again, you don't have to do it if you already got the hash. But again, yeah, same thing. I forgot about those things. Just start with this here. Again, let me just start again. Again, it has started the fake servers. It started poisoning the these protocols, and again, computer on this machine try to access this share. Okay, let me hit enter. If you go back to the Kali Linux machine, okay. If you see, it has started poisoning the server 01 location. Let's wait. Okay, I think I have to access it again, maybe. Okay, let's do one thing. Yeah, don't worry. Yeah, let's try to access it again. I think it was the we have tried it earlier, that's why it failed, but this time let me again try this. I have clicked enter, and again if you see, it is trying to poison the responses. Yeah, looks good. I might have to restart it. So, and oh yeah, again if you see, I think I got the hash. If you see, let me just pause it here. No. Okay, what happened here? Yeah. Okay, if you see, this is the IP address of my Kali Linux machine. Okay. Now we got a response from this workstation who is looking for a user from that workstation who is looking for the server 01 machine. We have responded back that, hey, we know server 01 machine. Basically, it is located at 10.0.0.17, which is the IP address of the Kali machine. Now that victim machine will go to the Kali Linux machine looking for the particular share on the server 01. And in response, we will ask for their authentication. And when the user will send their authentication, in the authentication message, there is this NTLM v2 hash. And we got the NTLM v2 hash of the user. The user name is Richard. So username is Richard. Okay. And we got the NTLM hash. Okay. I hope that's clear. So let me just copy this hash. As I said, what we can do with this hash, we can try to crack this hash. Let me just copy. Let me close this. Now let me create a file called let's say Richard hash. Let me just paste the same hash. Shift V X control 5 to save. Okay, let me just show this hash. So that's the hash NTLM v2 hash of the. So okay, so this hash. So what is this hash? Okay, I think let me just show you again which hash. This is what this hash is. This hash is nothing but. Let me go back to the slide. Then it will start making sense. Okay. So this hash is the response. This hash is the in the response. It has the NTLM v2 hash. So if you see, this time this response has reached us instead of this server machine. Okay, so this is the NTLM v2 hash. Now what we can do, we can crack the hash. So let's do that. Okay, I have already have command. Okay, let me just explain the command. Hashcat is the name of the tool, M is the mode, 5600 is the mode. So 5600 is for NTLM, cracking the NTLM v2 hashes. Then we will provide the Richard hash. So I have to provide a dash here. That's the name of the hash. Okay, so that's the hash that I have just saved, and then we have to use a word list. So if this user has a simple password and that password is stored in this word list, this hash is going to be cracked. So let's do that. Hit enter. Now the hashcat tool is trying to crack the hash of the Richard user. So let's wait for few seconds. Okay, again if you see, status is exhausted. So this basically the tool hashcat is not able to crack the hash. Okay, maybe why? Because the password of the user is not present in the word list. Maybe that user is using a secure and strong password. Okay, so sometimes if we get lucky and the user is using a simple password like password 123, this hash is going to be cracked and we will get the password of that user. But in this scenario, we were not able to do that. Again, just to showcase this hash, if you see this, just let me go back to slides again. See, this is the same hash. Okay, so it basically it will in the screenshot it is different because it will be different because the challenge it is sending will be different in every authentication request. So that's why the encryption will create some other hash. But anyways, what I am saying is that this is the response in which it will have the NTLM v2 hash. That's this hash. Okay, so ignore this part. I think it starts from 41. Okay, let me just show if it is there already in the slide. Yeah, if you see 411b2bdb, if you see here, I think in this scenario the name of the user is where is the name of the user is test, name of the domain is consultant, and if you see same here, name of the user test, consultant in the name of the domain, this is some random value, and from here the NTLM v2 hash starts and ends there. Okay, so that's what you also saw in my case. Since it is a different user, you have seen a different hash here. So yeah, again, the chances of compromising the password, cracking the password is based on it depends on the complexity of the password set by the user. Again, so in our real world engagements, what we do, we use this responder tool and we look for these hashes. Once we get a hash, then we try to crack the hash. If we are not able to crack the hash, what we can do, I am going to show here. So all is don't get disappointed if you are not able to crack the hash. Don't worry, because we have another attack which is going to complement this. Okay, let me go back to the slides. Because these are some of the references that you can use. Okay, so basically, okay, I have one question. So has it ever happened in real team engagement that even after running responder for the whole day, we did not get any NTLM hash? And what is the average time that we should keep running the responder? Okay, first thing, on the timing, it depends on the environment. If it is a very big environment, there is the probability of getting a hash is higher, right? So average time when you are asking me, so let's suppose I can give an example of, let's suppose there is an environment which has 1000 computers. Then every 2 or 3 minutes you are going to see a hash. Okay, it's that easy. Okay, so that's the average time here. And so there are some scenarios where we will not see the hash for the whole day. Why? Probably because we have pen tested that environment, and we have given them the proper recommendation, and when they come for a retest, at that time we see that sometimes we, even after giving them the recommendation, we also see sometimes again we see the hash. But most of the time we have pen tested them and they have fixed these protocols issues, then we might not get the hash for the whole day. But again, if you are working on a fresh environment, you are going to see a hash every 2 or 3 minutes. Average time you can take as 5 minutes. So keep it running, because you are going to get hashes of all sorts of user, all sorts of services. Okay, yeah, cool. So let's continue. Okay, as I said, let's suppose you are not able to crack the hash, right? What you can do, basically you can relay the hash. Okay, so this victim machine has sent the hash to you. Okay, now you have the hash. What you can use this hash? You can use this hash on different other machines. Okay, how it will happen? Let me show you. Okay, so Sanchit is asking for the recommendation. Don't worry, I will give a recommendation. I have a slide for that. So let's wait for that slide. Okay, so here comes the fun part here. Okay, as you can see, again you can see the client machine is looking for a share from a server. That server is not present in the network. Now, as an attacker, you have already poisoned that machine. Okay, we just saw in our practical that from a workstation we have poisoned the response for a workstation. Now that workstation is thinking that we are the one who is server 01. Okay, now the client machine will send the authentication request to the attacker machine, because it thinks that this attacker machine is the server 01 machine. Okay, because we have poisoned it, right? It has sent the authentication request to the attacker machine. But as an attacker machine, what we will do? Basically, we will take the same authentication request. Okay, let's suppose this is let's suppose the name of the user is Richard. Okay, then we will take the authentication request of this Richard user, and then using the same authentication request, we will ask each and every computer in the domain and use their authentication request to do some malicious things. Okay, basically we are not that helpful so that we can just give them the share, right? We are not going to do that. Basically, as an attacker, what we can do, we can take that and that authentication request, then we will ask to each and every server in the network that I am because I have the authentication request. It means every server will think that Richard is sending the request. Okay, because I have the authentication of the Richard, right? I can say that, hey, I am the Richard. I will ask each and every server in the domain and ask for their SAM hashes. SAM hashes, what are SAM hashes? So SAM hashes are the hash of the local users that are present on that particular machine. Okay, the SAM hash is the NTLM hash, not NTLM v2. It's the NTLM hash. NTLM hash we can use for logging in. Okay, NTLM net. Okay, when I say net NTLM v2, I am saying that net NTLM v2. Okay, so net NTLM v2 hashes we are not able to log in directly, right? But using the NTLM hash, we can log into the computers, right? So what we can do? Okay, so this is the authentication request that came to this attacker. The attacker will relay. It means forward this same authentication request to this server, and then this server will send back the attacker machine the NTLM challenge. What attacker will do? It is basically acting as a man in the middle. Okay, now it will take the same challenge. It will send back the same challenge to the client. Client machine, what will do? It will take the Richard hash, encrypt the challenge, and it will create the NTLM v2 hash. Basically, in this response, it will have the NTLM v2 hash. Now, this client machine will send back this NTLM v2 hash or the request to the attacker machine. Again, attacker machine, we can just take the same thing, forward it back to the server. Okay, the server will again think that it is coming from the Richard because we have already positioned it, right? We have the correct response. Okay, the server will simply thinks that hey, this is coming from it will forward this thing to the DC. DC will again do its operations. It will try to validate, compare both the hashes. Both the hashes looks correct because it is the response or NTLM v2 hash is generated by the Richard only, right? It will think that both the things matches. It will allow the authentication, right? If you see, this is asking for share, but using the same authentication request, we can ask for SAM hashes as well. Okay. Cool. Now, the server will think that hey, this is the correct user who is asking for the SAM hashes, which is the Richard user, and it will send back to this user the SAM hashes from this machine. What we can say to this client, hey, I don't have the share. Basically, it can just discard this request, but it will get this attacker will get the SAM hashes. And why it is able to get the SAM hashes? Why? Because why only because this Richard user is a local admin on this machine as well. Okay, this Richard. Let's suppose that this attacker has sent the authentication request to some other server, right? Okay, but on this computer, Richard is not the domain controller, so the Richard don't has the rights to access the SAM hashes also, right? It will not send back. But on this server machine, since Richard is the local admin, it can access the SAM hashes and send it back to the attacker. I hope now you know the NTLM relay attack. Cool. I hope everything makes sense here. Okay. So one very important thing here is that you can only relay that authentication to the systems who have SMB signing not enabled. Okay, if you see, if this server system had SMB signing enabled, if it is enabled, if it is enforced on this server, then the relay will not work. Okay, if the SMB signing is enabled, so the requirement is that SMB signing should be disabled. So you might have question, hey, what if in the network all the systems have SMB signing disabled, right? You will not able to go to perform the attack, right? You might have that question, right? But the reality is that on all the server machine and the workstation machine in the domain, SMB signing is by default disabled. Okay, so by default it is disabled on all the systems in the domain. On domain controller it's enabled, but on the server and workstations it is by default disabled. So don't worry about that. Okay, so don't worry about the SMB signing restriction here. Okay, so what is SMB signing? So SMB signing verifies the origin as well as authenticity of the SMB packets. So if SMB signing is enabled on a computer or on a server, it will first validate the origin. So if SMB signing is enabled, it will be able to verify whether the request is coming from attacker or it is coming from a legitimate machine. Okay, it verifies the origin of the machine. Okay, another thing, it will also verify the authenticity of the SMB packets. Basically, if there is any change by an attacker in the middle who is making any changes in the SMB packets, it will be able to detect that. Okay, so if you see, by default only domain controllers have SMB signing disabled and set to required. And which are the systems who are vulnerable? Okay, let me just draw here one more thing here. Okay, let me just draw it here. So on DC, by default it comes enabled plus required. Okay, on servers and workstations, by default it comes as disabled. Okay, but administrators can enable it, right? So even if they change from disabled to enabled, then also you can exploit this. Okay, even though it is enabled, the SMB signing is enabled, then also you will be able to exploit it, but it should be enabled and required. If it is enabled and required, then the SMB signing works properly and you will not be able to relay the hash. That's what is written here. Systems that are not vulnerable to relay attack have SMB signing configured to the following, which is SMB signing should be enabled and set to required. Okay, this is one of the protection that you can apply. Someone asking for the protection, you can apply SMB signing. You can set SMB signing as enabled and required. So this is how you can carry out a NTLM relay attack. Okay, this is how you can carry out a NTLM relay attack. You can use crackmap or netexec tool. So first you will basically find, okay, so using this command, first you are going to find systems which have SMB signing disabled, because only those systems are vulnerable to NTLM relay attack. Then you will turn off SMB and HTTP server on the responder. Why? Because now this time we are going to use another tool, this relay tool, which is going to be acting as a fake server. So we have to by default disable this SMB as well as HTTP server for responder. Okay, don't worry, I am going to showcase this practically, it will make more sense. Okay, one question, that is this relay attacks works only on SMB? That's not the case. So this relay based attacks works on other protocols as well. SMB is one of them. It also works on HTTP LDAP as well. Okay, yeah. So then, okay, so this is how you carry out this attack, and you will get the SAM hashes, and then you can basically verify whether the SAM hash is correct or not, and then you can basically spray this. So don't worry, I am going to showcase this practically. It will make much more sense. So let's start with the practicals, guys. Okay. Again, whatever attacks I am showcasing here, please do it on your own labs. Let me do one thing. This is what I intended to do. Anyway, let me Control Shift T for new tab, and then Control Shift R for this. So I am going to show side by side how it will work. Control Shift plus 1 2 3 4 5 6. Control Shift plus 1 2 3 4 5 6. I hope it's visible. It's visible. Okay, now let's carry out this attack. First thing that we can do, let's go it step by step. Okay, first thing that we will do, first let me change the configuration of the responder. So let's do that first. Nano. So the responder configuration file is stored in this location, user share responder, and the responder.conf file. And let me turn this off. Okay, I will explain why I am turning this off. Let me just first turn this off. Okay, let me save this. Now let me run this. So when I have turned that flags off, it means that this time the SMB server is turned off. If you see, SMB server is turned off, as well as HTTP server is also turned off. Main thing here is that SMB server is turned off. Okay, why we are turning HTTP and SMB server? Because the other tool, which is called Impacket's NTLM Relay X, is going to be hosting the these two servers. Okay, if these are on, it will conflict with this, and will not this tool will not run the NTLM Relay X. That's why we have to turn this off, because this time this tool and responder is going to be the poisoner tool, and this tool is going to ask for the authentication and then relay the authentication to other systems. Okay, so the first step is complete. The responder is running. Now let's try to find the systems which have SMB signing disabled. We can use netexec tool. Yeah, cool. So what we can do, we can, in this subnet, we can ask computers whether we can check whether if the system has SMB signing enabled or not. So let me just do this thing. Let me just run this again so that it will be visible to you guys. Still not. So let me just copy this command and run it in the different tab. Increase it and hit enter. This time you will be able to see. Okay, let me just decrease it. Sorry guys, because I want to make it looks even more smaller. I hope it is visible. What I am trying to see here, show you here, is this, that basically 1 2 3, because basically this is my host machine, so ignore this. But if you see on this web01 machine, which is hosted at this IP address, and this ws01 machine, both this machine has SMB signing as false. Okay, both these machines, web01 and web07, has SMB signing as false, but on the domain controller, both the domain controllers DC01, DC202, it has signing true. As I said that on domain controllers by default they have SMB signing enabled, but on the workstations as well as on the servers, SMB signing comes by default as disabled. So we got two systems here. So forget about this computer. This is my host machine. So we have web01 and web07, which both the addresses are this. Okay. Also let me show you my IP address. IP address of this Kali machine, which is 10.0.0.128, and these are the IP addresses of the machines which has SMB signing disabled that we are going to target. Okay. So let's create a file here. Okay. So we are going to create a file called SMB signing false hosts. Let's give the IP addresses 10.0.0.5, and we have, which is the server, and then 10.0.0.17, which is the workstation machine. Let's save it. Okay, now we have saved it. These are the two machines that I have added in this host file. Okay. Okay. So yeah, let me, so on this tab I have already responder running, which is processing the response, and on this tab let me run the impacket relay X tool, impacket NTLM Relay X. That's the name of the tool. Then I will provide the target file, which is this file, which has the SMB signing false hosts, and then I will also enable the SMB2 support as well, so that the systems who wants to use SMB2 as their protocol, they will also the queries will not fail. Okay. So let me just run this. So that's what we also do in our real world engagements. On one tab we will run the responder tool, on another tab we will run the impackets NTLM Relay X tool, and then what do? We wait. we generally don't wait. We will just keep it running, and then meanwhile on the we are enumerating the environment. Okay. We just don't sit and watch this window. Maybe after 5 or 6 minutes we will come back to this window and see if something comes up. Okay. Again, since this is a very small environment, you don't see, because I am the only one operating on this environment. So I have to make one mistake here. What a mistake I have to do? Simply I have to ask for a server that is not present in this network. Okay. Okay. So let's do. So now what I am doing from this WS01 machine. Okay. It's a workstation machine. Let me try to access Redfox share here. Okay. From this machine, server 01, I am trying to access the sys share, but this machine, the server machine, is not in the network. Again, what will happen? What will happen here is that first it will ask the domain controller looking for the IP address. Domain controller don't have the IP address, right? It will ask it will send a broadcast messages and ask each and every computer about the IP address of this server machine. Since we have already spoofed using the responder, we have already spoofing the responses, so that when the response will come to us, we will tell that this machine, that server 1 is located at the IP address that I control, basically my IP address. And when the server, then the workstation will come to the attacker machine looking for the server 01 machine. The attacker machine will ask for the authentication, and when the victim machine will send the authentication, with this victim machine send the authentication to the workstation, the attacker machine, this attacker machine can relay these hashes to the host which has SME signing disabled. We have two hosts in the machine which have SME signing disabled, which is the workstation, which is this machine itself, workstation 07, and we have another machine which is web 01. Okay, both have SME signing disabled. So I have tried to access this share, the Redfox share, and if we see here side by side, you see here, okay, if you see again, first it poisoned the responses, this server 01 response, okay, it poisoned it. Then the victim machine has sent this the relay, the authentication request to our machine, this machine, basically this machine, this tool is now acting as a fake SME server, right? So the authentication request has reached to this NTLM Relay tool. Now this NTLM Relay tool has taken that authentication and it has sent the authentication to these hosts, the host in this file, which are two hosts, and then from each the host, it will ask their NTLM, the SAM hashes. If you see in this case, okay. So in this case, if you see, let's see this one. So received connection for this user from this machine, connection will be relayed after re-authentication. Okay. Then this machine, okay, this connection, it is not targeting using the authentication. It is targeting the server, this web server, okay, which is located at this address. Cool. Now this Richard is a local admin on this web 01 machine as well. Since it is local admin, it can query the SAM hashes, and in the SAM hashes it will have the hash of the NTLM hash of the local administrator on this machine. Basically now on this machine, if you see, I think somewhere it is here that where it is, done dump. Okay, if you see, first it extracted the hash and then it says done dumping SAM hashes for host. This is the web 01 host. Okay, so this is the host. Again it has tried to do that again, that doesn't matter. If you see, it has taken the authentication request of the Richard user from the victim machine, which is the workstation machine, and it has relayed that authentication request to the web 01 server asking for the local SAM hashes, and the system has happily sent back the SAM hashes to the attacker machine. Now attacker machine has this. But one thing to note here is that, so this is done dumping for so it has done dumping for the web 01 machine, right? But if you see here, when it is trying to authenticate against the WS01 machine, which is located at this IP address, it has failed, right? Why it has failed? So the request has come from the WS01 machine, and we are targeting and we are relaying that to again back to the same machine, but it has failed. Okay, basically that user, see, I am already logged in on this computer. If you see, on this WS01 workstation, if you see, who am I? Okay, I am already a user logged in this computer. Okay, I think I can authenticate to this computer, but if you see, even before getting to the SAM hashes, even before querying the SAM hashes, the request has failed. Okay, it has not even tried reaching there. Okay, first thing, it will try to authenticate. Once the authentication is successful, if you see in this case, first it is trying to authenticate, and if the authentication is successful, okay, then only it tried to dump the hashes, right, in the case of Web01 machine. But in case of the workstation 0107 machine, it has even failed before authentication, right? Let me just draw this here, draw a diagram here, so that you guys get an idea what is actually is happening here in case of this scenario. Okay, let's draw this. So this is WS07 machine. This is the machines of my lab. This is the attacker machine, which is Kali. This is the Web01 machine. Okay, and Richard user is here. Okay, and also Richard user is here. This case, it is the local admin. Okay, let me do one thing, guys, again here for you guys. Let me make this user admin on this system. Okay, on this Web07 machine, make this user net slash sorry. Okay, if I remove this, will go out. Okay, anyways, so let me make this Richard user a local admin on this system. Access is denied. Okay, maybe because I am not a local administrator. So let me do one thing. Run the command prompt as administrator. Okay, now let me copy the same command. Paste it. Okay, now edit. Now if we see, okay, so basically let me first write the host name, which is the W701 machine, and the administrator. So now on this W70 machine, Richard is now also the administrator. Okay, now if I try to again, let me just rerun this tool again. Control C. Let me just close this thing. Again, let me rerun this. Okay. Again from this workstation machine, let me try to access a share. This time it is the local administrator. Okay, the Richard on the WS07 machine. So let me do one thing. Let me just okay. If you see, again, if you see the same thing from this Web01 machine, the authentication is successful and it has dumped the hashes from the Web01 machine. But still, even though Richard is a local administrator on this workstation, again the authentication has failed. Okay, so the reason is that, the reason I have to show you via a diagram here. Now again let me draw the diagram quickly. Okay, so let's do one thing. Yeah, on WS07 machine, Richard is the user. He is the local admin on this computer as well. Okay, and this is the attacker machine. Let me also try to the IP as well. Attacker machine, the server, this is the Web01 machine. Again here Richard is a user. I will show you whether he is local admin or not, but yeah, this is the local admin on this computer, and this is the attacker machine, which is Kali. Okay, so we get first we tried to access a fake share, it sent a broadcast request, it does, it poisoned that, and then it sent the authentication request to this Kali machine. Then we have forwarded that, let's suppose we have forwarded this request to this machine, and using the authentication of the Richard user, since we are local admin on this machine, we have dumped the SAM hashes. Okay, that I think you're able to understand. But when it again when it sent the authentication request to Kali machine, and the Kali machine asked for the SAM hashes for the same machine. Okay, if you see, it has asked Kali, and Kali is relaying to the same machine. In this case, it has failed. Why? Because you cannot relay the hash to the same computer from which it is coming from. Okay, actually we were able to do that I think 5 or 6 years back, but Windows has fixed it. So basically you cannot relay the same hash back to the same computer. That's why we are seeing the authentication has failed, because Windows has patched it. Okay, I hope it is clear now, but you can relay it to some other machine. And I was saying, let's see whether on this Web 01 machine, whether Richard is part of the local administrators or not. A net local group. You see, Richard is part of this local administrator group. That's why we were able to extract the SAM hashes from the server Web 01 machine. Okay, yeah, this machine. I hope that's clear now. What we can do now? So let me just close this. Let me just copy paste this this thing here. Copy selection. Let me just paste it here. Nano SAM hashes from Web 01 machine. Okay, let me just paste it here. Okay, save it, just cat it. You see, these are the local SAM hashes from this Web 01 machine, and if we see, we got the hash of a local administrator as well as some of the other normal users. But here, if you see, we have now escalated our privileges on this machine, because we are now the local administrator on this particular machine, which is Web 01, because we have this hash. Okay, so if we use this net exec command and verify this hash net on this computer. Okay, if you see, so I have taken this hash. So if you see this full, so this is in the format LM plus NTLM hash. Okay, so Windows has removed this now. So this is now the correct NTLM hash. It is the 32-bit character. Okay, so this is the same thing. Okay, so I am just trying to verify this local administrator, whether the hash of this local administrator is correct or not. And again, in the last, I have to give local auth, because it is a local administrator. So I have to use local authentication, not the domain authentication. And if you see, there is a pond here. It means that we have successfully compromised the Web 01 machine, because we have the hash NTLM hash of the administrator. Okay, so we cannot use our NTLM v2 hash here, right? It will not get successful. We can only NTLM hashes are used for authentic or for login requests. Okay, I hope that's clear. I hope so. That's the NTLM relay attack in action. And coming to the mitigations, how you can mitigate this? You can disable these protocols, the LMR, NBT or MDNS protocols, so that the broadcast request will be disabled. It will not reach the attacker machine. You can also have a network traffic filtration, so that this broadcast traffic will not reach to the attacker machine. And the best recommendation that we can give is that enable SMB signing and put it in the enforced or the required mode. Okay, so this is the value that you have to set, so that the attack will not work. So let's quickly do that as well. Okay, So where is this? H key local machine system control set. Okay. H key local machine control set. So I will go on this system. Let me open registry editor. Let me quickly change the setting. H key local machine. I think it was H key local machine system control set services. System control set services. Since this is a server, we are going to use LAN man server. So here we have to find LAN man server. So here it is. I just saw it. So that's the LAN man server. Under this, we have parameters, and we can set this. Require signature signing. Okay, so that's what we have to set. Set this from 0 to 1. Okay, if you enable this option, just enable, it will not work. You have to set this in the required mode. So require security signature. Okay, so I have set it to 1, and let's try to just close it, and then try to carry out the same attack again. And then again from this this machine, let's again try to access the same share. Maybe we can use any share, it doesn't matter if as long as this server name is incorrect here. If you see this here, let's wait. If you see, this time when it is sending a request to these systems, basically, yeah, if you see, where is that? Yeah, if you see status access denied, this time you get an error, access is denied. Why? Because SME signing is checking the packets. Okay, it is checking the origin as well as the authenticity of the request. Okay, so that's the whole NTLM relay attack in action. Plus I have shown you the recommendations as well.
Not sure where to begin in cybersecurity? At Redfox Academy, we make it simple. Start from zero and complete a course at your own pace. Our beginner-friendly courses walk you through everything you need to know, step by step. With expert instructors and plenty of hands-on practice, you'll be ready to take on real-world challenges. Whether you are interested in penetration testing, application security, we are here to guide you every step of the way. Visit academy.redfoxsec.com and start your learning journey with us today. Plus, you can avail up to 20% discount on our courses. The courses and coupon codes are provided in the lower section of the video.